Well, good day everyone. Hope everyone's well. Back to another episode of the Johnson Viking II transmitters. As you can see, this is one that has the unstandard two-tone paint scheme, gray and silver. So what I want to do is just do a little testing on this today. We'll probably make a multi-part video on restoring this old Viking II from doing the electrical, getting things up and running to see if it's even worth restoring. You know, if you got bad transformers and chokes and stuff in it, may not be worth putting the time in to restore. But if we get the thing working electrically, then we know from there if it's worth going any further on. So several issues that I've already went and checked out in this. The meter is not going to work, or is not working. Could be due to this front glass is sitting in here at an angle. You can see right there on the bottom, you can see a crack, and so the glass is sitting in there sideways, and it's probably up against the meter. That could be causing it not to work. I did some testing. I went ahead and checked for shorts while I was underneath the bottom of it to make sure none of these capacitors were shorted. I brought the unit up on a current limiting variac, and I noticed the oscillator is working. I can see a signal on the spectrum analyzer with the crystal that's installed in here on 3.993 megahertz. But when you go to flip the plate switch up, nothing at all happens. So we're going to get underneath the bottom of it. I did take the 807s out of the other Viking II and put in here just so that those two leads ain't just flying, hitting metal and causing any issues, just for testing purposes. So we're going to get underneath the bottom of it and look at this and see if we can figure out just what all going on. We might go ahead and look at this meter today also, and see if we can possibly get it to work. So one of the first things that gets your attention when you're looking at this is in the back supposed to be a crystal socket, and that is the antenna relay connection. They used a crystal socket in the Viking IIs. And you get here and you start looking, and the first thing you see is 3 wires sticking out the back out of where that socket used to be. So you wonder what in the world's going on there. Well, let me show you. So that one red wire that's sticking out the back, I can move it and I can see what it's going to. And when I look at it, it's connected right here to the positive lead of the line cord. So there's 120 volts sticking out back here on the wire. Not good at all. This is why you have to be very careful. Now, if you also noticed in our last video, I talked about this relay that's in here, and it looks like somebody's PTT mod. Well, one of the wires that is connected to one side of the coil of that relay goes out through that hole in the back. The other wire that's connected to the other side of the coil comes right up here to the bottom of the fuse connector, and this fuse connector is hooked directly to one side of the AC line. So they even got this on the wrong side. If they were going to do this, they should have put it on the fuse side, but they did not. So it's got power going to it all the time. And when you see stuff like that, there's no need of even trying to fix it. Snip it out, do away with it. Now the other wires on the relay just come right on over and go right to the back of the plate switch. So we'll go ahead and I'll snip all this out, and I'll come back later and clean off the ends and get all that cleaned up. But yeah, this is not a good thing to have. Now, you know, one thing I will say, the relay that they used is probably period correct for the time frame of when this Johnson was built. So yeah, they had maybe a good idea, but it just doesn't look right and doesn't look safe to me. This is all 20K modulation bias resistor, and I've checked it and it checked good. It's 20Ks and the tap is working, so we know that this resistor is good. Funny thing is, they used another resistor. They took the original resistor out, and this is also a slider resistor with the slide part removed, and it looks like a 20K also. So I'm going to have to check this out. I don't think that's correct neither, but we'll get to that a little further. Right now we want to figure out why it doesn't go in transmit mode and why the meter is not working. Okay, I got this old relay out, got it out of the way, and I started looking up here, and there is a wire missing off the plate switch, and it is actually one of these wires that's running out back. So no telling what kind of foolery they've been trying to do on this. So I'm gonna have to, and what that does is turns the high voltage transformers off and on, and it has been removed from the plate switch. So I'm gonna get in here and see if I can't troubleshoot through this and get that wire back reattached, and hopefully that'll have this fixed. Well, luckily the original wire was just hanging down here under the bottom, and I got all these little pieces of wires that I clipped off removed from the back of the switch, and have the other wires reattached on this end. And I went back and they were actually still attached on the other end. They just had some extra wires connected to them. I got all that cleaned out, so that should put the plate switch back in operation, hopefully. Alright, next thing I want to do is carefully remove this meter. We need to desolder these wires, take these two nuts out, get this little terminal strip out of the way, and then we can take the two big nuts off the back of the meter and carefully try to slide this thing out without causing any damage. We'll have to get into it and see just what it looks like in there. Okay, as you can see, I got the cover off, and you can do this without pulling the whole front faceplate. Just have to be very careful at doing it. The cover will come off if you hold it at an angle like this, and you see it'll drop right back in. So you can remove this meter without taking the front faceplate out. Just be very careful, you know, not to damage anything. So now that's out of the way. All I got to do is get in here and remove these 4 little standard screws, and we'll be able to slide the meter right out. Well, as you can see, the meter's out. The only problem is this bottom screw, which is the last one you take out. That would normally sit right here. You got to make sure you use a magnetized screwdriver, because it's very hard to get your fingers on that one. But the meter is out, and as you can see, the glass is loose in it. So we're going to have to go ahead and take this thing apart. So we get the cover off of it. I'm just going to remove these 3 screws from the outside. Someone's put some kind of glue on this, and it's in the slot of the screw. Let's clean all that off. Let's hope they didn't put too much glue in it, and they didn't. So our meter movement looks okay. Now there's ways to test meters. Do not ever put a voltmeter across this, because your voltmeter could accidentally blow the coil in the meter, and then you'll be in a world of trouble trying to find a replacement. And sure enough, the glass is completely loose. The ring is pushed back, not even in the slot to hold it in. So I'll need to clean all this up. And there's glue everywhere. Someone's tried to glue it from the outside. I'll have to get all this cleaned off. Then we'll put this meter back together and hopefully it'll work. Okay, our meter is all back together. And you can see the needle is moving freely. And while I was in there, see all this crud here laying on the bench? That's what all was in there. And some kind of glue. I had to take acetone and get it out. It's all in the meter movement everywhere. So yeah, somebody did a cobbled up job on that. Well, anyway, I'm going to get the meter remounted back in the rig, and we'll see if it works. Alright guys, so here's the moment of truth. We fixed the meter, we fixed the plate switch circuit, and I just want to see if we got anything going on here. So I'm in the CW mode, I'm on 80 meters. Oscillator, you can see you've got oscillator showing here. We'll go to buffer. Turn the drive up a little bit. And we're tuning out there. Let's look at our grid. I'll drive down, get it to about 8 milliamps. So that's working. Alright, we'll go to plate. Pull it up. Dip the plate. Plate dips fine. Okay, that is looking good. Let's take a look at the watt meter. And now we can see the watt meter on the plate switch back on, and we got about 110 watts output. Got the old microphone connected. Switch over to AM. Key to mic. Got the mic cranked up on the audio. Way too much carrier. Test 1, 2. No modulation. But we see we do have some audio issues, and it could be all those bad caps underneath. I'm not sure where the bias is set on the modulation current, but yeah, we got a long ways to go, but we're definitely getting there. Okay, so I can see why we don't have no modulation at all. someone used the wrong type of 1/4" jack. This is only a dual terminal. There's no ground tap on this at all. So your ground wire is connected to the center ring of your 1/4" jack, and let's see, no, your ground wire is connected to the to the tip. Yeah, ground wire is connected to the tip. Audio is connected to the center ring. The audio should be connected to the tip. The center ring would be transmit, and then the other lug would be ground. And this only has 2 lugs on this connector. So the bad thing about it, to get this off the front panel, does have to be poured out, because it's whoever put it in took the front panel off, mounted it to the front jack. Because you know, you don't want this to go all the way through and then put a nut on it, because it will squish the 2 panels together. So all this has to be tore out and replaced. But to check for audio, I can just move the wire on my microphone and run a ground lead, and we should better see if we have any audio. Okay, I got the scope connected up to this stage, and I've already checked it, and still there is no audio at all, nothing coming through on the scope. So that tells me either the interstage transformer is bad, or these capacitors and resistors, or possibly a tube is bad. So till we can get the parts in and get all these replaced and see if our interstage transformer is working, then we won't know if we have any modulation at all. Good thing about the way the Johnson is designed, you can connect here under this tube with a scope, and you don't even have to key it up, just speak in the microphone, and you should see the amplified signal on the scope. And this one, we're not seeing anything. Okay guys, at least now we know where we stand at on this particular Viking II. We'll have to get this front panel's got to come off anyway. So before I take the front panel off, I'll get another jack, and I'll probably just go back with a 1/4" jack like in there, and this way I don't have to drill out this hole for a 4-pin jack. I kind of like the 1/4" jacks better, and you only need 3 wires anyway, because I will be putting the PTT mod in this transmitter. And we'll get this thing tore down, start cleaning it up. We already see that it's electrically in good condition. It's just the cosmetics is so bad on it. So you know, we'll get this thing sanded down and strip off all this old paint, get some new paint on it, new decals, lettering, whatever, and clean up these knobs, get the inside cleaned up. But it'll be in multiple steps. Still got to order a set of 807s for this one, and we'll just see how it turns out. It looks like, you know, putting out full power, that it's going to be a pretty decent transmitter. So that was one good thing. So we'll just see how it goes. Still got the other one here. It's going to be probably just be, you know, recap, put in that new resistor, take that abomination in the audio bias circuit out, and we'll get that one together. That one should be pretty easy to get going. Should be no problems whatsoever with this one. Another thing I want to do is do some rearranging here on the bench. I want to probably take the bench apart and rearrange some test equipment. I like to have the watt meter down here so I can get the watt meter in the shop with whatever equipment I'm working on, instead of having to pan all the way up there to see the watt meter. But you know, they've been working on this here. You can barely see the IFR sitting back there. So yeah, I might need to do some rearranging in here, probably end of June when I take my week's vacation. We'll see how that goes along. Anyway, I probably will not bore y'all with the cleaning of this. Maybe we'll do, shoot some video on taking it apart, but mostly it's just blow it out, wipe everything down, and repaint the transformers and polish up the chassis on the inside. Just get it good and clean. I can always tell you, we don't have to clean it as like we did the first Johnson 2 video I did. That one was just terrible. I mean, it had been sitting in a very dirty place and had a lot of corrosion on it. This one here is just filthy. So I don't think the cleaning of it will be as bad. I really believe this one will clean up real good. We ain't got all that corrosion to deal with in this. One thing, the biggest thing that worries me about this transmitter is this choke here. And looking at this choke, let me zoom in on it here. You can see this waxy looking substance that come off of it. That's the wax inside the choke. And if you look here on these 3 coils, you'll see that same wax. And up on the side up here is a little spot of it. So it looks like this thing was laying on the other side at one time, and this choke had gotten hot and started dripping its wax out of this area right here, and it just run down on these 3 coils and then onto the other side. So what would cause this choke to get hot? Well, that particular choke is L2, and on either side of it you see these C1, I think, no, C11 and C10. There's 2 capacitors there. These are 15 microfarads at 450 volts. If either one of these capacitors, especially the one on this side, starts leaking heavily, it'll draw more current through this choke, and that's probably what has caused that choke to get hot. So I've got capacitors ordered for both of these and some more equipment that I'm working on, and they should be here next week sometime around between the 20th and 23rd. I ordered them from Just Radio, so they should be here soon. So when we take these caps out, we'll just check them for the fun of it and see if that's caused the problem, or if there was a cap in it before that caused the problem. But I'm pretty sure a bad capacitor has caused that choke to overheat. Now, looking at the audio stage, we know these capacitors are most likely bad, and that's probably why it's not passing any audio. I had audio up to this point on the first stage, and some audio out of the first speech processor or speech amplifier, but there's nothing coming out of the second tube. So I'm pretty sure these capacitors is bad. Now, I started looking at this, at the schematic, and I'll talk to you a little bit more about some modifications that's been done to Johnson. But somebody, I don't know if this was done when the first guy originally built it, or somebody came in here and tried to do something else. But you see this resistor right here, this 5-watt resistor. Let me pull the schematic on that. But if you look down here at V1, pin 5 is the plate, and if we look at the schematic here, We can see V1 and coming off the plate, which is pin 5 of the tube, and it goes on over this way, and you see this resistor right here, R3, should be a 470k resistor. And like I said, the schematic says coming off of pin 5 of this tube, which is the plate, that should be a 470k resistor. But if you look at this, 220k, and that is connected directly to pin 5, and then on pin 6 there's a 470k resistor. So I don't know what type of voodoo somebody was trying to do there, or what was going on, but yeah, we're just going to probably strip out this whole area and just completely redo it. I did go ahead and change out the mic jack, and I used a 1/4 inch instead of the 4-pin mic connector. And the reason for that, I've already had several boat anchors that's using a 1/4 inch mic jack, like by Swans and stuff, and I can share those same microphones back and forth with this rig. Now normally R13, which is the modulation bias resistor, is a 50 watt. This thing here has to be a 70 or 80 watt. It's 20k. It's a big resistor, a lot bigger than what normally would be in here. And I mean, it's okay the way it is. And you see they got the other 20k ohm resistor here, which is the same type. And I don't think they're ohmite resistors. I'm not sure what that is. I don't see a name on them. But if you notice here, the CW phone switch has been replaced. There's now a dual gang switch here. I don't know why they added that for. The whole front section doesn't look like it's used, but apparently the one that was in here went bad and they replaced it with a dual gang, which it works, but we'll look at if we can change it back to a single gang and get it back original looking. I will see no other reason to have a dual gang switch here. Anyway, thanks to Terry over at D-Lab for recommending where to get these 20k ohm slider resistors from. I picked up 2 from Allied Electronics, and when I got them in, I was a little bit surprised, but they're well packaged. But they do not come with the mounting feet. Now, you know, you say, alright, no problem, you know, you use the old mounting feet. But, however, in the other Johnson that's got the original paint on it, someone molested it and changed it over to sandbar resistors. Okay, I want to go ahead and get started on the electrical restoration of this Johnson Viking II transmitter. And someone might say, well, you know, why don't you clean it up first and then do the electrical restoration? Well, why go through all that labor of tearing this thing apart and cleaning it, and we don't know if it's going to work? But I can assure you that when we get finished with it, it's going to work just like it did the day it left the factory. I just have that much confidence in it. And one of the first places that we're going to start at is changing out these caps in the main power supply. Now, this cap here is suspect due to the way this filter has leaked. Like I say, at some point it has gotten hot, and you can see it has dripped the wax down onto these 3 coils and then onto the other side. So what we're going to do is tear this out, because I want to get these leads out and replace these leads with new leads going down to the terminal boards. So we'll go ahead and take all this little chokes here out, get them out of the way. We'll probably loosen up this transformer and get it down. Well, also we're going to have to test this thing and see just what's going on, and you know, make sure that it's not shorted, and that it has the right measurements on it. Now, one thing I don't have is a good LC meter. I have the Peak Atlas meter for ESR. I have the cheap Chinese testers that'll test capacitors, resistors, transistors, inductors, diodes, so forth, you know, but how accurate they are, I don't really know. It's just going to be a comparison. I'll compare one of the other filters and the other two Johnsons, and then we'll compare this one and just see if it's anything close. If not, we're going to have to either look for one of these or rewind this, which I really hate doing because it takes so much time to do. But you know, sometimes that's what you have to do. Maybe we can, if it's bad, maybe I can find one online. But anyway, yeah, I'm looking for a good LC meter. I like the Atlas meters, but like the one I have, which is the one right here, this is the ESR 70. It does a good job. It'll only read down to 1 microfarad. Anything below that, it will not read the capacitance. I can use my DMM, but it'll read everything though in nanofarads. So, you know, yeah, I do have that opportunity to use it, but I like to find a good dedicated meter for testing capacitor values and inductance and so forth. So I'll be looking around if anybody has any suggestions. Leave a comment down below. Alright, so what I'm going to do is go ahead and remove these this core assembly here for the line filters, and you know, we still got these wires sticking out back. But then the reason why I'm going to go ahead and remove that and go ahead and replace those wires, because I have a new ceramic crystal socket that we can install and wire in like it's supposed to be, and then we don't have those wires sticking out the back. So this is the original type of crystal socket that Johnson would have used in these rigs. And to start to get this out, there's just 2 little screws in here. We'll have to loosen those up and take the ground runners off, and then we can pull this back out of the way. So as I got in here and I got this out, got the capacitor, one side of it loose, one side of the core loose. The book says it's 15 Henry, and I checked it on the my old meter here. So if I connect this up to the circuit, or to the filter, and we test it. I'm taking line, you know, also the long leads. It's checking at 13.7 Henry and has a resistance of 379.9, which I think sounds about right. So I don't think the capacitor is what caused the that filter to heat up. If we look here, whoever installed this line cord, they got the ground coming up here to this strip. They have the white wire tied to this side, which goes to the fuse. That should be the black wire. And they have the black wire tied to the center coil, and it should be tied over here to feed the circuit. So yeah, a little bit of trickery going on there, so I'm going to have to strip all this out and redo it and wear this cord. There's not even a strain relief on this, so if somebody was to pull the cord, it would pull directly on to these terminals and could have broken and shorted something out. So I'm going to go ahead and get this changed around, and then we'll worry about getting the caps in and the little crystal socket. And just for giggles, let's test this capacitor and see if it was the problem of heating that filter up. I'm checking one side. Now this is a dual cap. You can see it's checking 21.34 microfarad at an ESR of 0.48. It's out of spec. And we'll check the other side. There should be 15 microfarad. And it's checking 24.52 with an ESR of 0.58 ohms. So this capacitor was not causing the filter choke to heat up. And what it was the incorrect wiring on the AC line that was causing it. Okay, now I told you wrong on the AC wiring. Your black wire will go to this coil and your white wire will go to this coil. They had them on these two coils, which is completely wrong. So instead of running the wires and putting them up on the top like they had them, I'm going to utilize these pins here on the bottom. And all I'm going to do, I'm going to just solder a lug into there and then bend it up. And that way that'll give us a place to hook our AC wiring. Now this is how it's done in some of the Johnsons. Why it's not done in this one, I do not know. Okay, I got those two terminals soldered on. And when I notice this, you can see this terminal here that's going to the fuse. And look what's happened. Come right off, not even soldered on properly. Okay, the AC line cord is now properly wired back in. I've got two wires coming from the tube back here to connect those 15 microfarad capacitors up with. And I have installed the ceramic crystal socket. So now we can go ahead and get the new filter caps in. So you know your filter caps go in the standard way. The positive will go to these two wires and then the negative will go to ground. Now this other filter capacitor, it is 15 microfarads at 150 volts and it's a dual cap. And make sure that when you install this that your negative actually goes up here to the tube on the two pins, and your positive goes to ground on this. This is your negative supply, so make sure you don't get those backwards. Okay, so both of them old big filter caps are out. We got the new ones installed. And you see I just used one terminal board, and there's a ground lug here for these two filter caps, and the two 160 volt caps just go to this one ground lug here. Again, you know, the negative goes towards the tube. And since, if you notice, since I had it, I also used this old style cloth covering wire. This was the stuff I picked up some time back, and it makes for a good looking job when you know, restoring these old radios. Now they didn't use a lot of cloth covered wires in this. You know, you see most of this is just plastic coated, but your transformers and your chokes in these do have the cloth covered wire. So now that all this whole section is fixed, we can move on to something else. I went ahead and reinstalled the front panel, and that'll have, the reason for that, because this will make testing a lot easier without having to guess where each knob is sitting at when we do power this up. But I want to go ahead now and replace some of these other capacitors. And there is one that's tucked down in here, and there's one here on this terminal strip, and then we got all these in the audio chain. But I want him to go ahead and get these tested, and then we can test out the radio and see just how it does. Then we'll look at going through this audio section, because, you know, like I said, I'm seeing some things in here that just doesn't look right. Now, the other two Vikings and the manual are basically built the same way. This one is different a little bit. If you notice, V28 and R30 are mounted on this little board. In the other two radios, these are actually punched through the chassis, and the tube and the shaft for this VR goes out the top. Now, I do not know, I think I mentioned this before, the exact period of when this Viking II was built, but I'm really thinking this is an older one. But look here on this capacitor, this 8 microfarad capacitor, it's got a code of 230 on it. On the other one it has a 308, and on my personal Viking there is no code. It's got everything else is the same, but it's in bigger, bolder letters, like, you know, it's a newer style. I've gone through here, I've looked for trying to find different date codes, and I'm not able to find anything. So I am thinking that this is perhaps an early Johnson Viking II. But anyway, I'm gonna go ahead and get these two caps here replaced, and then we'll look at powering this rig up and seeing just what it looks like, and then we'll test the audio section. Again, there's some differences in this that I'm not too sure of, and we'll have to look through it, but I'll get a closer look at it now. So you see this capacitor that's coming from the VR for the audio gains coming down to V1. This is standard. It's in all of them. It's in the other two that have been replaced. This one actually has 5 capacitors in this bank, and over here on this terminal strip there's an extra resistor. Now, I think I said before, from the output of V1 should go through a 470k resistor, and this is not designed like that. It's got a lower value resistor, 22k coming through here, and there's some other things going on here that's not the same. So yeah, we're just probably going to just rip all this out and build it like the other two Viking IIs are. So before I get started on trying to tune this thing, I checked all the controls, and I noticed that immediately this buffer control has completely froze up on me while turning it. So I went ahead and got it unwired, and I've loosened up the 2 nuts on the bracket. I'm not going to take them completely out because they're very hard to get to with the front panel back on. Move the knob back off, and I think I got it so I can get a wrench on the front of it and take the nut off, and I'll go ahead and get that pulled out. Well, here it is. I got it completely out. I finally had to go ahead and take this bracket off. I was able to get one nut off by using a 1/2 inch wrench, but I couldn't get the other one off. Now, this would have been bent at about 15 degrees. It would have went in there and got it. But it's no problem. Nothing's going to fall. These screws goes right up into the ceramic standoffs or small coil up in that hole, so they stayed in place, so no problem. But yeah, this thing is completely frozen. So I think what I'm going to have to do is remove this little C-clip that's right here and clean this shaft up and see if I can tap it out without breaking this ceramic. That's going to be fun. Well, I was actually able to get it out without too much difficulty. You can see just which that shaft is. So I can go ahead and clean this up and lube it, and hopefully put it back together and it'll work alright. Okay, my control now turns with no problems. So we can get this back installed, give it a good cleaning already, so should be good to go now. Okay, we're going to try it again. Brought the unit back up. Like I say, when I went to get that bubble control, it turned and then automatically froze. We on CW, got on 80 meters. You can see we showing a little current on the meter. I have it on oscillator. We're going to switch it over to buffer. Pick up the oscillator. More drive. Put it up on grid. Pick our buffer out. Oh yeah. There we go. We can turn the drive down a little bit. About 5 to 8 milliamps. And we're going to switch the plate on and dip that meter real quickly. It's already dipped, showing about 110 watts on the meter. Go back and look at our grid. Still at about 8 to 10 milliamps, so that looks good. Switch it over to phone. Okay, we're going to go back to plate. We're going to switch to, okay, we're going to switch over to phone. Meter on plate. Just want to drop just a little bit. And we are pulling modulator current. I got our microphone connected. Turn up the audio a little bit. Still on modulation. Go back to plate. Test 1 2. Test 1 2. No audio whatsoever. So now we got to troubleshoot the audio section, which I'm pretty sure it's going to be those bad filter caps. I'm pretty sure it's going to be those capacitors and resistors in that audio section that we'll need to look at now. Alright, I got the scope connected to pin 1 of that first 6AU6. And let's go ahead and pan over to the scope. And we can take a look, and we see we do have audio going into the tube. I've connected to pin 5, which is the plate of that 6AU6. Test 1 2. 1 2. And we do have some audio coming out of it, but it is a little weak. There's capacitors on that output that could be causing a problem. So this is where it gets where it doesn't work. I'm on pin 1 of the second 6AU6. That's the input, and there is hardly anything. I can turn it wide open. Check 1 2. Just can't see a little ripple on the scope. So yeah, our modulation is not even making it to that tube. So best thing to do is go ahead and strip out these caps, and let's put it back together like it's supposed to be. and get some new fresh ones in it. Well guys, after a long decision and looking at this circuit, I went ahead and got in there and just stripped out the whole preamplifier section of this Viking II. I mean, I looked at it and I said, there's no way that this can pass audio from the second stage over to the 807s. It just, the way it was wired up, it just couldn't work. And in doing that, I went ahead and removed that interstage transformer, and it's sitting right here on the bench. Okay, so I got the meter out. I want to go ahead and just show you what I found. I'll go in between the two primaries. This one wants to be a little hard to get to. Look at that. Nothing. Nothing at all. So the primary is open. We look at the secondary across the two outside terminals. It's about 116 ohm, and to the center tap about 107 ohm. So the secondary looks okay, but the primary is open, and I'm wondering that whatever modification they were doing, if they somehow shorted out the primary of this interstage transformer. So I guess I'll have to go online, pick up a Hammond 124B and put in this thing, about 50 bucks. So that should take care of that problem, and then rebuild this circuit back the way it's supposed to be. Again, you know, there's some strange things with this transmitter that I don't see in the other ones or in the schematic. Again, V28 is sitting on this platform with R30. That's no problem. Up here on this little terminal tie board, the center tap for the interstage transformer goes to the central terminal, and then here there is a resistor, and then it has a capacitor going from here to pin 7 of V2. No idea why. Very strange. I went ahead and just popped the paper back on this little transformer, and just to see, but yeah, there's one lead here and there's one lead here, and they are still connected to each one of the primary wires. So no fixing that. It can be fixed, but it's not worth tearing apart and rewinding. You can get a new one for 50 bucks, especially the way it looks like. The primary is on the inside and the secondary is on the outside, which means you would have to completely remove the secondaries just to get down to the primary. So yep, she's no good. Well, as you guys can see, a lot of dead soldiers here. All the capacitors, handful of resistors. V2 is completely dead, along with the interstage transformer. So, and in the next video we'll go in and we'll go ahead and rebuild the preamp, put in a new transformer. There's a few other little things, odds and ends in this rig that's got to be done. The VFO cable, as you can see, it does not have a shield around it, and someone's got a little orange wire going to ground, and the other end should be fed with a capacitor. Normally there's a terminal tie strip here with the coax going in it, then a capacitor going over here to the wafer switch, and there's not, so we'll have to take care of that. So hope y'all picked up something. Like I say, we'll get this other parts we needed ordered and get them in part 2, and then start some of the probably cosmetic restorations in part 3. So part 2 will be finishing up the electrical restoration, clean and lube all the switches, getting everything tuned in, make sure it's working, get the modulator current right, and then part 3 will do some cosmetic work. Anyway, I hope you enjoyed it. I'd like to hear your comments down below. If you would hit that like button, that always helps. You can follow me over on Patreon if you want to support the channel, and we'll see you in the next video. Bye now.